All right, this goes along with the PowerPoint on the immune system, obviously. I usually like to talk through this in person, but I'm just gonna go through the PowerPoint and identify a couple areas to point out, and then when we get together, we can have time to go through stuff. The first one is just kind of taking you way back into those glory days of anatomy, physiology, those kind of things, just reminding you some basic stuff. There's not much of a question that comes out of here, but you should have just an idea of kind of how the immune system is set up. The fact that there is lymphatic waste and we have a lymph system and where those vessels are, where, what the spleen does and where this stuff comes from. So you don't have to know who Vanilla Ice is, but you may know the song. You definitely should know who this person is, even though he's probably irrelevant now. But anyway, here's some of the things. I am going to go through a little bit of the immune system, and I want you to kind of have an idea of, definitely want you to have an idea of the fact that our bodies produce these things called antibodies, which are going to attack and destroy outside invading substances and materials and organisms and all that kind of stuff. These terms, immunoglobulin, gamma globulin, they just make you sound smart. Actually, you might be smart, but you don't have to know about that for this class. These are just types of antibodies, or when you see IgE or IgG or Ig any letter, really, these are just individual antibodies that get produced based on specific things. And so especially when you look at allergy stuff, you'll see a lot of IgE. There's actual drugs that prevent these specific antibodies from taking effect or antagonize those. So definitely want you to know this term, the concept of an antibody, and then of course the antigen, right? So you get, maybe the antigen should have come first, the chicken or the egg. The antigen should come first because this is the substance or anything that the body sees as foreign and harmful. And so it's going to trigger an immune response. It may be bacteria, viruses, something that is actually harmful, but it also may be a pollen or a bee sting or food, right? That's not necessarily going to kill you, but the actual immune response starts to affect your normal functions and actually could get into an anaphylactic and even death if it's gone unaffected right there. So you have to know antigens, you have to know antibodies. There are thousands of different, each antibody is specific to this kind or this specific bacteria versus another specific bacteria, all that kind of stuff. They deactivate, especially in the world of viruses. And then it also kind of marks these antigens for the other system, that general system that's going to come in here with this complement system, that the specific proteins that are going to come in and destroy some of these things. The other things of the immune system you should have an idea of is, number one, where are these, where are our white and red blood cells produced? But then in our white blood cells on the immune system side, you should have an idea that macrophages and phagocytosis, that's that process of these cells that go and engulf the foreign substance and basically dissolves it. Then you have specific cells like T cells and B cells that are producing specific antibodies for each individual antigen, or these are your T cells right here. These are the actual killers that will go out and destroy whatever the foreign substance is that has been marked, kind of thing. As we look at our body's ability to fight off any kind of infection and what our immune system has at its disposal, we have a lot of components here that are part of the immune system. So these are on the next couple slides that we're going to talk about. You guys have this little chart. I'm just going to fill it in for you and do that kind of stuff. So ultimately, anytime the immune system is triggered, there's a general response that goes throughout the entire body. And then obviously these are the specific ones specific to the actual antigen, whether it's an allergic, like pollen, or if it's a specific virus, whether it's the flu virus or COVID or some other virus, you're going to have a specific response. So we get really specific, and then we just do general, right? So this happens every time, and it doesn't always it's not always 100%. It's not on and off. There is, depending on the type of the antigen and how harmful it is. So as we go through here, I'll let you can kind of read through the general stuff. I'll point out a couple stuff. I already mentioned this: neutralizing and marking them for destruction. The general is what creates that fever part, that febrile state. And then these are important components right here. I'm going to point this out. In fact, I would note this, because I could ask a question about this, is that depending on the extent of a general immune response, our body starts to take from itself to fight the infection. And so long-term infections, especially like stuff like cancers, or where the immune system is just nonstop going, the body starts to waste away. And so that does occur as we go through there. The other thing that's kind of interesting from a performance standpoint right here, so you can see that. And then this insulin part is interesting too. So when diabetics are sick, they need to be a little bit more on watch, as far as there could be differences in how their glucose is going up and down and doing that kind of stuff. So then we get to the specific. This is obviously specific to a certain antigen, virus, bacteria, those kind of things. And so the T cells are the ones that actually go out and are in charge of deploying and destroying these kind of things. The B cells are what produce the antibodies, so that if we ever come in contact with that again, those antigens now will respond a lot quicker, instead of waiting for these T cells to get to the different site. But now that we have antibodies throughout our body in the plasma, we can respond and kill things a little bit quicker. And sometimes we don't even realize we came in contact with that flu virus again, or we may feel, I kind of feel like I'm getting sick, and then you don't. That may be something that like that. All right, I do want to talk about immunity and the levels of protection that are there, just because just like in any prevention, just because we have a preventative mechanism doesn't mean we're not going to get that condition, right? So just like if you're going to go out into the cold weather, right, and you don't want to be cold, you layer up, you put a lot of protection on there. The longer you're out there, or if it's really, really cold, it still may get cold, right? Same thing with our protective equipment, right? Just because we wear a bunch of padding, and then this guy gets tackled, and he may hit him right here in the chest, right where all these nice pads are. This protection is there, but he gets a chest contusion or breaks a rib. Doesn't mean that we're going to stop that shoulder pads don't work. It just means that force was more than the protection was giving him. So as far as the immunity, I equate that with protection. As you see, the different types of immunity are there. Right, so we actually heard a little bit more about this with COVID, this concept of natural immunity once we have antibodies and a specific response ready. The problem with COVID and other flus and other viruses like that, the problem is that it's like strain specific. So once these little viruses mutate, then the antibodies aren't as effective, and you start getting a little bit more of that general response again. Vaccines, the traditional form of vaccines is to take a inactive or weakened form of the pathogen, so we can, basically we're trying to initiate natural immunity. And then if we can get to a point that through these vaccines, if you can become protected to the point where you won't get it again, then we call that more that immunization, right? So the flu vaccine that people get every year, you're not getting immunized against the flu. You're getting a vaccine for that specific strain. If you get like a shingles vaccine that's available, and that prevents you from getting it for an extended period of time, then that's more of an immunization. It's not just an ongoing type situation. This is the thing. These are the questions that I referred to in your assignment. There's a lot of feelings, thoughts, information out there about immunity and vaccine, that kind of stuff. And so these are some of the questions and some of the concepts you've heard before. Are these true? Are these not? This is the list that I referred to that you can use to go search for your own literature on these topics. So if you want to talk about vaccines contain a bunch of mercury and mercury is bad for you, that kind of stuff. The natural immunity is better, is it not? There's a lot of this. There's only two. I only put two on here, but there's a lot of questions about the recent mRNA vaccines that COVID brought to us and brought to light. So there's all kinds of things that you can jump into and kind of identify. So that's what the assignment is about for you guys to find out. In general, right? So this is the last couple of slides before I wrap up part one. In general, right? So when we're exercising and practicing and doing all that kind of stuff, what does it have on our immune system? You can see it right here. Typically, there's a little bit of a suppression, but no risk of infection has been identified. So that's good, right? When we are sick, when we have an active infection, a couple of things. This is not 100% take it to the bank, rules here, but in general, bacterial infections aren't going to get worse from this. They may get worse, but not necessarily from exercise. And then the viruses, typically, that suppression allows those viruses to continue to multiply and get into other areas. So ultimately, exercise kind of delays and suppresses that immune response. So typically when somebody has a fever, because of the inhibition of those metabolic pathways and performance, it's usually that's kind of the signal to just kind of step out and not do it. All right, I'm going to end this one here, and we'll start with part two.